Listen students, in the previous video I already explained the geometrical representation of a zero of a polynomial. I took the example of a linear polynomial, quadratic polynomial. Similarly also you can take a cubic polynomial. So what conclusion we got there? For a linear polynomial, uh, the zeros of the linear polynomial is 1, because the graph of the linear polynomial is exactly intersecting at x-axis in only one point. That means the graph of the linear polynomial is intersecting at the x-axis at exactly one point. That's why the zeros of the linear polynomial is 1. Similarly, the zeros of quadratic polynomial is at most 2. That means sometimes in some type of examples of a quadratic polynomial you will get no real zeros. Sometimes you will get two equal zeros. Sometimes also you will get two distinct zeros. So three different cases already I have explained in my previous video about the zeros. Similarly, for cubic polynomial also, the cubic polynomial also have at most 3 zeros. A cubic polynomial, remember, a cubic polynomial have at most 3 zeros. Also you can represent graphically, you can find the zeros of the cubic polynomial graphically, how I have explained for linear polynomial and cubic polynomial. But you remember, linear polynomial have exactly 1 zero, and quadratic polynomial have at most 2 zeros, and cubic polynomial have at most 3 zeros. Now I am going to explain one example. It's a very important, this one. Listen, look at the graphs given below. Each of the graph y is equal to p of x, where p of x is a polynomial. For each of the graphs, find the number of zeros of p of x. Here given one polynomial in terms of p of x. Here given a polynomial in terms of p of x, and observe the graphs. Here 6 different graphs are there. Observe the graphs and find the number of zeros in each graphs. You have to find the number of zeros in each graphs. Remember, if polynomial is given p of x, then see at x-axis the graph intersect the x-axis at how many points? Remember, if p of x is given the polynomial in terms of x, then in order to find the number of zeros, you observe the graph intersect the x-axis at how many points. If the graph intersect the x-axis in a single point, in figure number 1, see the graph of this polynomial intersect at x-axis only in one point. So the number of zeros of this polynomial is 1. So the number of zero of this polynomial is 1. Similarly, the graph in the second figure, the graph intersect the x-axis at two different points. So the number of zeros for this graph is 2. Similarly, only x-axis intercept you have to see, because the polynomial is in terms of p of x. Here the graph intersect the x-axis at 3 different points, 1, 2, 3. So the number of zeros here 3. Here the graph intersect in one point, so the number of zeros is 1. But here the graph intersect the x-axis at exactly one point, so the number of zeros is 1. Here the graph intersect the x-axis at 1, 2, 3, 4. 4 different points. So the number of zeros for this graph is 4. Understood? You have to check at x-axis the graph intersect how many points. That means the graph intersect the x-axis in how many points. That number of points is the number of zeros. Suppose in the same graph, the polynomial given p of y. Suppose in the same graph the polynomial given p of y. Then we have to see in y-axis the graph intersect at how many points. I repeat, if the polynomial given in terms of p of y, suppose x is equal, here given y is equal to p of x, if here given x is equal to p of y, then the polynomial in which the variable is y, here we have to see the graph intersect the y-axis at how many points. In this graph, the graph intersect the y-axis at only one point. That's why here also number of zeros is 1. But here if y is equal to p of x, then the number of zeros is 3. If x is equal to p of y, you have to see in y-axis the graph intersect the y-axis at only one point, so that the number of zeros is 1 when the polynomial is x is equal to p of y. Understood? Similarly, here the number of zeros is 4 if the polynomial in terms of x. If the polynomial in terms of y, you have to see for y-intercept. The graph intersect the y-axis at only one point, so that the number of zeros will be 1. The number of zero will be 1 for this graph if the polynomial is in terms of y. If the polynomial is in terms of y. Understood?